Hello. I'm going to wait a second to before I start. Hello. Go ahead and spread the word if someone is not on the YouTube live stream. Hello, Sarah. Hello, Hannah. Gonna wait like one more minute. Gonna wait like one more minute. Gonna wait like. Hello. Just trying to give people some time to locate us. Hello. Okay. So it says I have 10 concurrent viewers. That's not the entire class, but well, they can just watch it later if they missed it. All right, welcome to day 2 of IB Physics SL. I have a couple of items that I want to go over. First of all, the attendance today will be the daily attendance button that is in Canvas. So if you haven't done that already, go ahead and submit your attendance on Canvas. You need to know your student ID in order to do that. Okay. The second thing I wanted to say is I think my lesson today might be half an hour in length, something like that. And immediately following my YouTube lesson, you will go back to the Zoom room that we were at yesterday. So that's kind of where the question and answer happens. And at that time, we will work on your daily assignment together. Okay? Because remember, every single day that we have class, I will give you a short 3 to 5 question assignment. While I'm giving the YouTube lesson, if you have any questions for me, please type them into the live chat. I'm monitoring the live chat currently, so I can see what you're saying. And then let's see. If I'm unable to answer any of your questions during the live chat or during the Zoom session, I will be here today in office hours, which is from 1:30 to 2:30. All right. So I think that's all that stuff. So what are we going to do for this class? Well, basically, we're going to take some notes today. So I'm going to switch over to this view. Oh, you know what? I forgot to grab my calculator. I'm going to grab my calculator. While I do that, while I grab my calculator, go ahead and get out. But if you're going to take notes, go ahead and get out a piece of paper. If that's what you want to do, you don't have to take notes. But I'll be right back. I got to grab my calculator. All right. Okay, awesome. Welcome to physics. First of all, I want to talk about just what is physics a little bit. And I would say that physics, if I were to define physics, it is a predictive model of the universe. Okay? So we can predict what's going to happen. So that's what we're going to learn. We're going to learn some rules for predicting what is going to happen. But before we can make any realistic predictions, we need to sort of build a foundation. Okay. So we're going to talk about 3 different concepts today. The first concept is the concept of position. Okay. And typically I'll denote position by X. X for position. I might denote it by Y if it's something that's moving vertically. Okay. And so all position is a number that represents where you are with respect to an origin. Okay, so an important thing there is the origin matters. Okay, because what are the coordinates of the origin in your math class? The coordinates of the origin are 0. So the origin defines where is position 0, and then we measure with respect to that. Okay. If I put square brackets around a quantity, like position, that means units of. What are the units of position? Okay. So units of position, we are going to use the units of position, which are meters, M. So meters are going to be our units of position. I'll give you a second to think about what do you think this would mean, units of T. What variable do you think T represents? I'll give you a second. If you thought T represents time, you're correct. So T, units of time, which are seconds. Okay. Some other things I might do, I might put subscripts. Okay. So for example, if I put a 0, that's a little 0. I don't know if you can read that, but a little 0 next to the variable. That means initial. So this would be the initial position. Okay? Initial position. If you put a subscript F, F stands for final. Okay? So this is T sub F, so that would mean final time. So subscripts give you more information about the variable because your position can change. You're walking around, you start someplace, you end someplace else. So you have initial and final positions, initial and final times, etc. The initial time of this class was, I think, 9:10. The final time for this class will be 10:10. Okay. All right. So there's a thing called displacement. Okay. Displacement is the change in position. Okay. Displacement is the change in position. So it is your final position minus your initial position. So you take your starting position or your final position, you subtract away your initial position. This has a fancy name. We call this, or it has a fancy symbol. We call it delta x. So this right here is the Greek letter delta. Okay, and it basically means change in. So anytime you see delta, delta means final value of this minus initial value of that. So it doesn't matter if it's a position or not. So we could say delta t is final time minus initial time. So that's kind of the time elapsed. All right. Okay. So So we're talking about motion in just along the x-axis. So let's draw a number line. Here's x measured in meters. And let's say we have something where, and here's x equals 0, so that's the origin. All right. Now, what if we have something at x equals 21 meters? And then it goes to x equals, let's say, minus 5 meters. All right. Okay. So how did it move? Well, this would be, so if you go from here to here, that's the final location. This is the initial location. So I want to take these and subtract them. The final location is 21. The initial location is, or sorry, the final, I'm tired this morning. The final location is minus 5. The initial location is 21, so I do minus 5 minus 21 is negative 26 meters was the displacement. Now, one of the things you'll notice about displacements is if delta x is less than 0, so if you had a negative displacement, that means you moved in the negative direction. Okay? So in this case, on the number line, that would mean you moved to the left. If delta x is greater than 0, you moved in the positive direction. All right? So the sign of delta x tells you which way you moved. Let's talk really briefly about two-dimensional displacements. Okay, if you have a 2D displacement, so let's say I go from here, so this is my initial spot, to my final spot, which is over here. Okay. I think I can turn this light up now. And let's say I go woo, I take a crazy two-dimensional path, and I end up there. Okay. The displacement, the size of the displacement is just the distance between the starting point and the ending point. So that's the displacement, the size of that distance. So you would kind of use the distance formula from your math class, the distance formula, like the Pythagorean theorem, kind of, to get that distance. So notice that displacement doesn't care about the detailed path that you took to go from your starting point to the ending point. Okay? What does matter, though, what does care about this is something called distance traveled. Okay? So distance traveled, I'll denote that by S. That would be the actual length of this line. Okay? So however long, so this would be the distance traveled. All right? So let's do a really simple example here. What if we have a circle of radius r? Okay? Here's the radius of the circle. Let's say you go around the circle once. What was your displacement for that? Well, your displacement equals 0 meters. Why? Because recall that displacement is the change in position, final position minus initial position. If you go around a circle, you start and stop at the same point. So these two are equal. You subtract them, and you get 0. Okay? The distance traveled, on the other hand, distance traveled would be equal to the circumference of the circle. Okay? So that would be 2 pi r, that many meters. All right? Again, I encourage you to ask any questions if you have them in the live chat. So there's displacement, there's distance traveled. And there's a slight difference between the two. Okay? Next thing I want to talk about is velocity. Which is denoted by v. And velocity is the rate of change of position. Okay? So there's a formula for it. It is displacement over time. Displacement over change in time, I should say. One of the things about, so this is, I'll box that in. One of the things about displacement and change in time, you might be tempted to cross-cancel the deltas. So for example, if you had a math expression like a times b over a times c, you know, you could obviously cross-cancel out the a's. But the thing about this is that delta x is a single variable. It's not delta times x. It's the single variable delta x. So you can't cancel out the deltas. Okay? So it's the variable, the single variable delta x divided by the single variable delta t. So what are the units of velocity? Well, velocity is a displacement divided by a time. Okay, so uh, so it's a displacement divided by a time, and displacement is measured in meters. Time is measured in seconds. So velocity is measured in meters per second. Okay. Of course, miles per hour is also a unit of velocity. But we're going to be using the metric system basically, so we're going to use meters per second. Okay. This equation can be rearranged using algebra in all different kinds of ways. You could, if you knew the velocity and the change in time, you could solve for the displacement, etc. Another way to think about velocity is that it is speed with direction. Okay? Speed with direction. So it's how fast you're going, and then also it includes the direction of travel. So what if I said you have a velocity of 60 meters per second in the eastward direction? That is a velocity. Okay. What if I said you had a velocity of 60 meters per second in the westward direction? These are different velocities. Okay. These are different velocities because velocity includes the direction. However, they are the same speed. Okay, same speed, but different velocities. Okay. So I will go to the next thing. So let's do an example with velocity. Okay. So let's say a grandma moves from x equals, let's say, x equals, can you guys read that? X equals 7 meters to x equals minus 1 meters in 4 seconds. What was grandma's velocity? Okay. So what we would do is we would say, well, gee, so this is the initial position because grandma starts at x equals 7. This is x naught. This is where grandma ends up. So that is x final position. So we figure out the displacement. The displacement is delta x equals final position minus initial position. Final position is -1. Initial position is 7. So -1 minus 7. That is a displacement of -8 meters. Then we have that the velocity is displacement over time. So that would be -8 meters in how many seconds? 4 seconds. 4 seconds was the time elapsed. So divided by 4 seconds equals -2 meters per second. Okay? So that would be the answer. One of the things that you can note is that velocity works just like displacement does. Okay, remember, displacement is negative if you moved in the negative direction. It's positive if you moved in the positive direction. Okay. Similarly, velocity is going to be positive if you're moving in the positive direction. It's going to be negative if you're moving in the negative direction. If you're moving two-dimensionally, not just back and forth, but two-dimensionally, then we would have to use sort of like cardinal directions to, north, south, east, west to describe where you're headed. But if we're just moving back and forth, then we use positive and negative. Okay. So that's velocity. And then the last thing we're going to talk about is something called acceleration, which is denoted by A. And acceleration is defined as the rate of change of velocity. So how quickly is the velocity changing? All right. Another way you could think about acceleration, this is what, when I remember when I was in high school, I took physics, and my physics teacher described acceleration as how fast you get fast. It's how fast you get fast. That being said, there is a second way you can accelerate besides changing your speed, because notice how acceleration is the rate of change of velocity. What does velocity have in addition to your speed? Okay, it also has direction. Velocity is speed with direction. So if your velocity is changing, it can change in two ways. It can change via speeding up or slowing down, and it can change via changing the direction that you're going in. Okay? So for example, if you're driving around in a circle, just going like that, even if the speedometer says you're going 50 miles per hour in the circle, you're actually accelerating because you're changing the direction that the car is pointing. Okay? So I'm going to add to that. I'm going to say it's how fast you get fast or change direction. Okay? So what is the formula for acceleration? The acceleration is rate of change of velocity. So the thing that's changing is velocity. So we have change in velocity, and then it's how quickly does it change. So we divide it by time. All right? Change in velocity over change in time. That's the acceleration. Units of acceleration. Well, an acceleration is a velocity divided by a time. So that would be a meter per second divided by a second. So that would be meters per second, which is called a meter per second squared. Okay? A common way that acceleration is talked about in cars is you might have heard of the 0 to 60 time. You might say, like, this BMW can go from 0 to 60 in 4 seconds. That's acceleration because the change in velocity is 60 miles per hour. The change in time is 4 seconds. So it's a rate of change of velocity. Okay? So what I'd like to do now is I would like to go ahead and switch over to the Zoom room, and I assigned some practice problems for displacement, velocity, and acceleration. And we're just going to go in the Zoom room and we're all going to work on the problems together. Okay? So I'm going to end my stream and I will meet you in the Zoom room in about 1 minute. Okay?